Hello, so today we are going to do problems from weekly contest 336, this week's contest. The second problem is rearrange array to maximize prefix score. So what we have here is we have an array and we can rearrange the elements in any order we want. We have a definition of a prefix array where basically it's just the sum of the elements after rearranging the array in any order we want. And so the prefix I would be the sum of all the elements from 0 to I, right? And we call a score of numbers basically the number of positive integers in this prefix array of the entire array, right? And the goal is to return what is the maximum score we can achieve with all the arrangement possible, right? So for example, with this here, what we can do is arrange it in a way where we have 2, 3, 1, minus 1, minus 3, 0, minus 3. That way the prefix sum is this, right? And from there, what we can have is we will have 1, 2, 3, 4, 5, 6. We would have 6 positive in the prefix array. So the score basically is the number of positive integers, okay? And so that's the maximum we can have. With this one, since we want only strictly positive, so not equal to 0, so not equal to 0 and not negative, with this array, there is basically just not possible. With any arrangement you can do, you will have either 0 or a negative number, and so we return 0. So that's the idea. Now how do we solve it? Okay, so how do we solve this? Well, intuitively, right, we want to do the prefix, right? And the prefix is just the sum. So if you add a negative number, right, the prefix will only go down, right? But if you add a positive number, the prefix will go up, just intuitively, right? And so it's always better to put the positive elements first, because then you would get a higher chance of having positive prefixes, right? Between the choice of minus 3 and 2, which one is better to put in the beginning so that you can have a prefix, as long of a prefix positive values as possible? It's always better to put 2, because 2 will increase the value, and so, but minus 3 will decrease the value. So let's say you have 1, if you use minus 3, you are going to end up with minus 2 as the prefix. If you use 2, you will end up with 3 as the prefix. So it's always better to put the positive values first. So from that single observation, that means let's just sort the array in decreasing order so that we have the positive values, if there are any, first. That way you maximize the number of the positive prefixes. And so to do that, we can just have 2, 3. So if we sort this array in decreasing order, then we would have 3 first, 2, 1, 0, minus 1, minus 3, minus 3, right? So minus 1, minus 3, minus 3, okay? And then we have 3, 2, 0, 1, 1, 0, right? Okay, so with this sorted array, we can just calculate the prefix array. Remember, the prefix is just the sum, the cumulative sum as we traverse the array. So we'd have 3, 5, 6, 6, minus 1 will give us 5, minus 3 will give us 2, and then this here will give us minus 1, right? And you can see with this, we get 6, which is the highest possible we can have, right? And this happened because we put the highest values first, so that way the prefix sum was made as highest as possible, right? Because if you add a negative value, it will only be smaller. So that's sort of the strategy we can make, which is greedy, and we can just sort in decreasing order. And in terms of time complexity, this is going to be O of n log n, because we are sorting. And then we are using, so that's going to be O of n log n time, right? With the sorting, and then we are doing one traversal to do the to create the prefix, right? And then we are calculating how many of these are positive, right? So both of these are going to be O of n, and so this actually is the bigger term. So this is the time complexity. In terms of space, we are using this extra prefix array, so that would be O of n space. But I'll show you when we do the implementation, there is a way to actually make it O of 1, right? Because we don't need the array, we just need to do a rolling sum, a cumulative sum as we go, and each time it's positive, we just need to increment the counter, right? Yeah, so that's pretty much it. Now let's implement it and make sure it passes. Okay, so let's implement this solution. So the first thing we need to do, as we said, is we need to sort the array in decreasing order. So I'll just use reverse true. And then we need to create a prefix array. So I'll do first the O of n solution, and then from there we can simplify it to O of 1 space, of course. And so this is going to be for the length of the array. So let's call it length of nums, right? And then we will just create our prefix, right? So in range of 1 to n. Now prefix, because the formula is that prefix of I is going to take the prefix of the previous subarray, right? Plus the current number. Let's also just make this called n to make this easier for ourselves. So because of this I minus 1, to not go out of bound, we are going to start from 1. But in that case, we need to fill index 0. And so index 0 is going to be just the number, the first number, right? And then from this, what we need to do is we can just go through the prefix array and count the positive ones, right? And so to do that, we'll just go through the prefix values. If the value is negative, we should stop, right? Because we have a decreasing array. So once it becomes negative, it will keep becoming negative. And also equal to 0, because the problem says we only count strictly positive, right? And so if this is the case, then we want to break completely, right? And then otherwise, it means it's positive, so we need to count it, right? So this is basically an else, which means p is bigger than 0, which means we need to count it. That's what the problem asks us to do. So we can't get rid of this else because we are doing this break here, right? And now we can just increment the count and return the count. Okay, so let's just make sure this passes. Looks good. Let's submit. And looks good. Now, we don't need, so this is O of n log n time because of the sorting. And the space is O of n space because of the prefix array. So let's get rid of this prefix array, because all we are doing is just having a rolling sum. So instead of doing actually this p prefix, let's just go through the elements, right? So let's just go through the numbers in the array. And let's have the prefix as a rolling sum, just a single value. So how do we do that then? Then each time we just need to say prefix is plus the number, because each time we just add the new number, right? And if that prefix is smaller than 0, then we stop, because we will only get smaller values, and this will only be even more negative, right? And so we break in that case, but otherwise we count it, because that means the prefix is bigger than 0, right? And that should work. We don't need this length. And so we can just run this and submit, and that passes as well. Now this solution is still over log n time, but we are not using any extra space. We are just using 2 variables, so O of 1 space. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.